Hello children, how are you all? I hope all are well. See, in the last few classes we understood about optics and all. In this class we'll try to understand the last chapter of 6th standard CBSE, that is fun with magnets. We'll try to understand the chapter fun with magnets. The fun with magnets, the chapter we'll try to understand now. Yeah. See, why this chapter is given in the 6th standard means you have played very well regarding with the magnet, right children? Many times we taken some like a cylinder magnet, spherical magnets, and we played using that magnet. Some you taken some paper, upon down the paper you just going to piece of magnet, and upon you just taken the powder of iron filling something, and you played the games of bus driving and all. So all this childhood games what we made, no? So why this going to attract this magnet only? Why attract other metals won't? Why it does not attract? So questions of all this you are curious. We're going to understand this chapter. What is magnet? And then suppose you will take any magnet. So see here you can observe, no, the magnet is some shape of the magnet is a different kind of shape. Some U-shaped magnet is there. You can observe here all the iron fillings, paper clips, nails, all this kind of things are attracted to magnet. And some kind of thing, let us take this paper, something you put here, it won't attract to this magnet. So why it is? So all these questions we'll try to understand in this class, that is fun with magnets. While learning we have the fun, okay? So we'll just try to understand this chapter in that manner. Okay, first of all try to understand what is magnet. Many times we know what magnet is, means like some dark color metal, it is what observing, no, we are just observing, it is in different shapes, you will get black one, okay, in the cylindrical, spiral shape, elliptical shape, so many magnets you saw. And in case of radios and all, you say like a disc shaped magnet, round shaped magnet, many you observed in the nature. Okay, in your homes, some in electrical graduates, you observed all these radios and all. But what is this magnet means according to physics? What this magnet means? See, magnet is a substance. It is a first of all substance which is naturally occurring first of all. It attracts the piece of iron towards itself. Right, children? You take any magnet, put to the iron, it will going to attract. In yourself on cupboards, will have any iron bearers, the iron armorers. In that you have some round color stickers. So how you attach round stickers using the back, you can turn and see. They have even the magnetic disc. Okay, small magnetic disk, using that you're going to stick files. And nowadays some alphabets also, for the alphabet they're going to use small magnetic piece, it will going to attract to magnetic boards. So all the kinds will work. That is what we call fun with magnet. Any substance which attract towards itself, okay, the any substance is a magnet is a kind of substance which will attract magnetic substance towards itself, like iron towards itself. That is what we call magnet. And it is always comes to rest in north south direction when you suspend freely. Okay, when you are going to suspend the magnet freely with some rigid support using the thread, it will always comes in north south direction. So you know what is north south direction? We have earth having a two poles like north pole and south pole. You just to freely suspend this magnet, it will come and align in the direction of north south. So exactly why it going to attract north north, and why it will going to attract south end to the south direction. So what is the reason behind this? Okay, everything we'll going to understand in this lesson. Clear children, what is magnet? Try to understand. It is a kind of substance which will going to attract magnetic materials, like iron is a magnetic material. Any other magnetic material it will attract? Yes, definitely it will attract another magnetic materials also, like cobalt, nickel. Okay, all this everything we are going to learn. Yeah, this magnet have the property to attract another things. Clear children? That property of a magnet, what we call as a magnetism. Okay, you know earth, whatever the object is that it will going to attract towards the earth. Suppose you have a pen in your hand, just to leave the pen, what happen? It will get to come down. Why it will come down? Because of gravity. Like that, a magnet is attracting other object because of it having a property called magnetism. We call magnetism is a property of a magnet to attract the things made up of iron, cobalt, nickel. You can see now here iron, cobalt, nickel. All these three materials are the examples of magnetic materials. They have the property to attract. This magnet has a property to attract magnetic material, what we call as magnetic materials. Clear children, what are magnetic materials? Yes, magnetism means the property of a magnet to attract the things made up of iron, cobalt, nickel is known as magnetism. Okay, you go to little higher classes, you just understand what is this magnetism, how it will work, what are the formulas of it, try to understand, everything you'll understand. Okay. See, if you take any magnet, let us imagine we taken one magnet. Around this magnet, they have a field. That means up to this distance, not only need not be a contact, but up to certain distance, it will going to attract another magnet. Suppose you place another magnet here, it will try to attract a repel. Or if you take any iron fillings in this area, let us take one steel spoon or a metal spoon you're going to take, that metal going to attract it towards magnet even though it is not in contact. Clear children, that is what we call the magnetic field. It will exist field around this. Because of that field is present, no, that is why it will going to attract another magnet. That is what you know earth having a gravitational field. That is why if you drop any object, so it will attract it towards the earth. The gravity means only attractive property, but magnet is not like that. It have both attraction and the sometimes you just reverse the direction of magnet, it will repels also. Both attraction and repulsion will be there for magnet. Okay, that is what magnetic field have both attraction repulsive property. So what is this field means? The area surrounding the magnet in which the magnetic force is exerted to attract the iron is known as magnetic field. Suppose this is a magnet I am taken, this magnet exert a field around this. So in this field, if any other magnet or any magnetic material you brought, it will try to attract towards it. If you out of the field, it won't attract. It has some range to attract. No, suppose you can extend your hand up to some limit. So like that, magnet also extend its field to some extent, so that it will try to attract another magnet. Okay, but earth, you can take the earth example, up to 150 kilometers above the earth, it have the atmosphere. That means it is going to attract all the gases. If it more than that height, it will go like escapes, it will escape from the earth, it won't attract back. Like that, magnet also is a field force. Okay, magnetic force is a field force. It have the field around this. Clear children, what is magnet? Actually, we're going to divide the forces into two types, children. If you go little higher classes, everything I'm going to explain detailedly. Now try to understand simple way. Force we can divide into two types. One is contact forces and non-contact forces. Contact forces means suppose I need to take a pen to the hand. What I do? I need to touch and we need to take the pen. That means what here is a contact force. I require contact. Then only it will come. So contact force. What is a muscular force? That is all the wheels and go no. That a cart. Suppose some bullock carts will pulling the cart. That is because of they have the attraction property. That means they're going to touch and they're going to take. That is what we call contact forces. Clear children? Contact force like a muscular force is a contact and a friction. Any object is moving on another surface, it's going to stop after moving some distance. That is what we call friction. Okay, all these are contact forces. Let us take non-contact forces like your magnetic force is a non-contact force and the gravitational force is also non-contact without any contact also. Suppose I just leave the earth is there down in between earth and this pin, so much distance is there, there is no contact. Even though if I leave, it will come down, it will attract it towards the earth. That is what we call gravitational, sorry, at non-contact forces. Okay children, non-contact forces is clear. So magnetic force is a kind of non-contact force. So in non-contact forces are what we call as a field forces. They will exert a field around that. Suppose you have some small magnet, a spherical magnet here, that magnet will exert a field around this. Suppose in this field any another object will come, like magnetic material will brought, it will going to attract towards that object. That is what called as a magnetic field. And the magnetic field lines of force originate from north pole of the magnet and end at the south pole. Suppose let us take the type of a magnet that is Bohr magnet. Okay, north pole and south pole they have always magnetic lines of force. They need to start, that means they will to originate, they will generate at the north and they're going to end at the south. It is not like a half semicircle, it will complete inside the magnet. The field lines they will move from south to north like this direction. So magnetic field lines are complete circle like this. Okay children, for your understanding, magnetic field lines are complete circle. They will start at north and they're going to end at the south. That is why north pole and one more north pole if we bring. Okay, to north pole. Why they going to repel? Because to north pole, what happened? Magnetic lines of force are coming. Here also magnetic force lines are coming. Here also magnetic field lines are coming. Let us imagine two water pipes. If the forcibly water is coming this and this end, they will just repel, they won't attract. Suppose this end is open pipe, this end is water is coming, then this will attract that water. In both the sides water is pushing and coming, what happen? They're going to repel each other. Try to understand, children, this one logically. If a why only north will repel, many times you learned they will repel, that is no very known property. North poles are south and south pole will repel, but why? Nobody will explain right for you why they will repel, and why north and south and north will attract. Right, children? This important questions you need to know, because your age is very small. You need to logically think logically. So much concept, no, you need to understand clearly. That is what my intention. So that's why I made all these videos. Yeah, try to understand now why north and north pole or south and south pole repel. First of all, we try to understand why they're going to repel. See, let us imagine now two pipes. Okay, imagine two pipes where let us this is an earth and this is an earth. So what happened in two pipes? Let us take two water pipes. Water is coming forcibly from the two ends. This end water is coming in this direction. This end also water is coming in this direction. So both the side water is coming forcibly. What will happen? It will move away from this direction. It will also move away from this direction. They will repel each other. Okay, they're going to repel each other like enemies. They're going to repel. Suppose if one water in one pipe water is coming and other pipe is empty, so what will happen that time? This water will go into this, so that it will going to attract this pipe towards this side. Okay, if it is the opposite end, like one is full, one is not full, it will attract. Both are filled, they both will repel, they won't attract. Clear, children? So that is why we can tell magnet has a two poles. No, one is north pole and a south pole. When they are like poles, north and north or south and south, they're going to attract each other. They're going to attract each other. And if you have south and north or north and south, they're going to repel each other. I hope this is clear, children. What is magnetic lines of force means? The field lines they will go into. That's imaginary lines. That is field. How it a field will be? It is imagined like it will start from north and it will going to end at the south. Like this. It will start at north, it will going to end at the south. So that you can see here all the lines are starting here, ending here, starting here, ending here. That means number of lines per unit area you can see are more. But here you can see number of lines are less. That is why you call that the pole's strength is more. Okay, number of lines is more, then we can pole has a more energy, that means more strength. That is why suppose you will take one magnet and put iron fillings on this and remove the magnet after some time, and you just see the magnet will be having more coils or more iron fillings attached at the poles. At the middle, very less, one or two going to attract that cell. That means what it indicates, at the poles having more strength. Clear, children? Poles having more strength compared to the middle. Okay, this is about magnet poles or magnetic lines of force. They're going to start at north and they're going to end at south, and this magnetic lines of force they never intersect each other, because at the same point of time the direction only one direction is possible. Okay, two directions is not at all possible, you need to go in one direction. So magnetic lines of force never intersect. Inside a magnet it will move from south to the north. This is about magnetic lines of force and the magnetic field. Here you can observe here north pole and south pole. See, you can observe carefully. The magnetic lines of force are generating at the north and they end at the south. Clear, children? They generating at the north and ending at the south. And inside you can see it is moving from south to the north. This is what we call magnetic lines of force. Clear, children? What are magnetic lines of force? You'll go little higher classes, no? Everything you're going to understand. Okay. This is what we call magnetism. Yeah, you can also hear children clearly. You can see we just done this experiment really. We take an iron fillings and a nut. So this is actually the bar magnet available in the your laboratories. This is bar kind. You are eating no Kit Kat bar like that. So bar magnet is there here. They take an iron filling. These are all iron fillings, are places of iron, very fine powder of iron. Now you're going to pour this powder and just rotate this magnet, this like and this like. Just first you pour the iron over the floor like one paper, and you taken the bar magnet and kept in between, and just to tilt the paper or just to tap the paper 3 to 4 times. After you some time you can observe all the fillings that try to accumulate at the poles more. You can observe here the iron fillings are accumulated where it is more at the poles. Then in middle only one or two is attracted. This shows that pole strength is more. Okay, children, see magnetic lines are coming from the node. You can see here in small area so many lines. Here same area with only 2 lines. That means more number of the lines are coming. That means more persons means more strength. Less persons, less strength, right children? We have 10%, we can fight all enemies. We have only 1% or 2%, we can use not fight. That means our strength is less here, your strength will be more. So ends of a magnet where the magnetic force is concentrated are called as a magnetic poles. Okay. And each magnet having the 2 poles, that is north pole and the south pole. You know very well each magnet. Suppose even you can take the circular magnet, a disk magnet. One face is north and other face, opposite face was you observe, no? That face will be the south face. Okay, like the north face and the south face. How are you going to understand this north face and south face means? Suppose this is a magnet, you are seeing from this end. The if suppose current is flow in this direction, okay, you can observe this in north. Okay, this is Andali going to learn, it will go for higher classes. Now if I explain also it will be difficult to understand. Leave it. According to a 6th grade, try to understand it having the 2 poles, north pole and the south pole. Even whatever the shape of the magnet you will take, you don't know shape of the different magnet, cylindrical magnet, horseshoe magnet, this horseshoe or U-shaped magnet or bar magnet or dumbbell bell magnet, all the kinds of magnet having a north pole, south pole, north pole, south pole. 2 poles they have, north and south pole. But never one pole never exists. Suppose imagine I have one magnet containing north pole and south pole. Imagine this magnet only. I just break into half. What happened? It will become this side is north and this side I break in four is south. But this kind of thing is not at all possible. Again, that cut piece again containing the south pole and here is north pole. Again, I am going to divide this north pole, south pole. It not possible. Again, there exists south pole and again this side exists north pole. So, how many pieces also you are going to cut this magnet into fine number of pieces? Even the small piece again contains north pole and south pole. So, what we are going to tell is that monopole. Okay, monopole never exists. Clear children? In case of magnetism or magnet, monopole never exists. But in case of electricity, that monopole exists. But in case of this magnetic poles, only single pole does not exist. Always occur in pairs. This is clear children? Yeah, I hope this is clear everyone. Yeah, we'll try to understand the types of magnets here. There are 2 types of magnets. One is artificial magnets and the natural magnets. See, grease, in place of grease like magnesia, one of the person like a sheep head. Okay, he'll going to taken the ships to the some forest sandal for grazing. So what happened one day? One day he taken there's a ships to the forest, like a big stones and all, forest and some hills he taken. So what happened one day? This is he carrying one stick. Okay, he control the goats. He carrying one stick. That stick contain at the end it is a metal base. Okay, it contain a metal base actually. So what happened when that metal base is attract to one kind of stone. Okay, that metal base is attached to one kind of the stone actually. So what he so some kind of stone is there. When he is going and passing, that metal base is a kind come and attracted this. So when it is attracted, what he knows, just he confused why it is attracted, because the stick won't attract to stones, right? But it's attracted. So again, some of the persons in that field area, they did experiments on that stone and they come to know that that is a magnet. Okay, again they noted that is a magnet. Okay, naturally occurring magnet, what we call as a lodestone. Okay, lodestone. Olden days they using this lodestone to find the directions and all. Naturally occurring magnet. or we also called it as a magnetite. Magnetite or magnet. They have very low power, okay, low magnetic power. It has very low magnetic power. We want to increase its power, we need to create artificially. How we going to create artificially magnet? By single touch method or double touch method. Suppose you taken one bar magnet, keep on the table, okay, then you take one small iron strip, very thin iron strip you're going to take like a blade, razor blade, and try to rub along this direction. We're going to take this and rub. So like this only we need to repeat the cycle. Okay, 10 to 20 times you will do. After that, this razor blade, what is that will try to attract another magnets, or it will try to attract another iron piece. That shows that it act like a temporary magnet. That is what we call electromagnet. Okay, temporary magnet will going to create by single or double touch method, or good method nowadays what they are using is that by passing electricity. When electricity or electrons are going inside your conductor, outside magnetic field going to produce. Okay, like this they're going to create a artificial magnets. So how to create, what is magnetic effect, okay, that and all we're going to learn in higher classes. I hope this is clear, children. Yes, next we'll try to understand how this magnet will. Okay. See, this is a different shape of magnet. First one is like a bar shape, bar magnet. Second one you can see English alphabet U. There is a U shape, are also called horseshoe magnet. And these are different patterns of a magnet. We can use it in almaras and all. You can see different missionary parts and all. You can see that spear shape, a cylindrical shape, spherical shape magnet. And the last one, see, that is used in the compass box. Okay, the diamond shape, what you can see, or you can call rhombus shaped magnet, that is used in compass box. This is a compass needle, actually very small needle shaped magnets also we're going to use. This is a different shape of artificial magnets, man-made magnets or artificial magnets we call. And you can see here horseshoe magnet, war magnet, magnetic needles, disc magnet. So all are different types of magnets. And here in see this a compass box, how the compass, magnetic compass work. Yeah, it's important actually for you as exam point of view. See, compass box contains north-south, you can observe, north-south direction and east-west direction perpendicular to each other like this. North-south, north-south, east-west are perpendicular. And in between that, north-east, south-west like that. Again, 4 is a sub. Okay, north-east, south-west like that. Now, if this is the, what is a pointer, you can see, the Nile, that is not a iron thing. It is a made up of magnet. Okay, it is a magnetic strip, a very small magnetic strip. So you can observe here pointer, that pointer shows north, and if without coating, it's painted with a black here, that is north. Without coating, that is the south. When you suspend this freely, you can see here to here some rod is there. It is like some, you can see from sideway, it will come from the some rod, the pointer is supporting. Okay, when you're going to rotate this one, you can easily rotating around some like this screw is provided. In case of your watches, you can observe in watches and all how the needles, our hand will rotate, like that this will also rotate. So how it will rotate? Because if we show any magnet, if you place this one in a magnetic field, okay, in the magnet, suppose it's a north south magnet, bar magnet, you brought nearby, what happened, this north, it is a north end, that north end will going to attract towards the south, so that it will show deflection. So based on that, which direction they are going, old and the soilers and all, and the navy person, they are going in boats and the ships. In case of big water, they can see an entire thing will be water. They're not giving any kilometer boats in the water or a sea. Are they going in flights and they don't have any kilometer boats there? So how they going to find the direction? Using this compass box. Okay, do you know what is what is this property? That is called directional property. Directional property of a magnet. Directional property of a magnet shows that the magnetic needle always points in north south direction. Okay, magnetic needle always points in north south direction, which is not north south, that we can take it as east west. So like that, we're going to take the magnetic compass will going to work. Clear, children, how magnetic compass will work? So some of the magnetic substances you observe, Which are the some magnetic substances here? Iron, cobalt, nickel, steel, alloys of above, all are the magnetic materials. So there are naturally occurring some alloys. Using that we are going to create the some permanent magnets actually. Okay children, please know the better. Iron is very important question. For 1 mark they are going to ask these questions. Cobalt, nickel, iron, steel and alloys of some other metals. And the properties of a magnet is they attract the magnetic materials like iron, nickel, cobalt and freely suspend. What happen? They always comes in a north-south direction. Like poles repel each other, unlike poles will attract each other. And you can observe here poles, unlike poles, how they're repelling and how they're attracting. And laws of magnet. Okay, laws of magnet you can see. This is little higher class for you. You'll understand there. And you can see the figure north, north, south, south, how they are attracting and repelling. And magnetic poles always exist in pairs. So here you can see, no, they always exist in pairs. They never exist alone. Always exist in pairs. Two. If we can cut the magnet into how many number of pieces also, again each piece again will have like a north pole and a south pole. Here see, you can observe here the big magnet we cut into two pieces. Again the two pieces again will have north south direction. Again that small piece we can divide into four pieces. Again that four pieces also having north south direction. So like this magnet never exists in single pole. And induced magnetism. You're going to induce the magnet by single touch method. I don't know. So single touch method or double touch method, we're going to induce the magnetism into the soft iron bars. Or are we going to make the permanent magnets? Okay, this is a permanent magnet we're going to do by using this soft iron. Okay, soft iron have the property that we're going to make them into an artificial by single touch method. I told you, you take one table, upon that you will keep one magnet, natural magnet or bar magnet, and take your iron strip, like a soft iron strip, try to rotate in the north direction only up to 20 to 30 times. You just rotate it without lifting your hand. It will be act like, again this iron strip act like a magnet sometime. So this is a by temporary. Okay, this is all temporary. You want to make it permanently, then you have to use electricity method. By passing electricity, you can able to create the magnetism, and that will be permanent magnets are brought, okay, near the soft iron bar, and soft iron bar becomes an induced magnet like this. Okay, if you brought nearby, it will become an induced. And magnetic induction, opposite poles always induce and two like poles faces each other is observed during the magnetic induction. Okay, this and all into little higher classes now. You'll try to understand this, children. Now it is difficult for you. No need of confusing so much. And see what we are thinking so far. Why bar magnet? If you're going to suspend, okay, when you're going to suspend the bar magnet freely, it will always align in north south direction. So far we have that out. No, just we're going to take one stand. Okay, some stand we're going to take and for that one stick, and here we have one thread. Just to connect the bar magnet with some thread. We're going to twist this like this. We're going to twist and leave. If you leave any direction, you're going to twist like this or like this. So after twisting, you're going to leave it freely. After few time, it will always comes in north south direction only. So always come and align in north south direction. Why? So because that reason is Earth has a big magnet. Earth will be act like a big magnet actually. Our Earth will act like a big magnet. Having, geography when you study, no, Earth having two poles of a magnet. Okay, you have studied, no, North Pole and South Pole of a magnet. Yes, children, you studied this, right? What is the North Pole and South Pole of of Earth? Okay, poles and equator, poles, everything you learned in geography. There's an equator and these are the poles. In case of this equator and poles, what you observe, near the north pole, actually magnetic south pole is located, and near the geographical north pole. This is a geographical north pole. Here the magnetic south pole there, and in the geographical south pole, magnetic north pole is there. Okay, that is why you're going to suspend any magnet like this. what happened? The magnet always, let us take this is north and south pole, they always try, what happened, north, what happened, they're going to repel, so it's going to twist it back again, it will be come and align in a direction of what, north and the south. Are you clear, children? If you suspend like south and north, it won't be there, because the south going to repel each other, and this north and north going to repel each other, so it will just trying to couple or twist in the direction and freely suspend in the direction of north south direction only. I think this is clear, children. Why magnet always comes in north south direction? Because geographical north, what we are thinking, in the geographical north, magnetic south pole is there. Okay, magnetic south pole is there, and geographical south pole, magnetic north pole is there. So that is why they're going to align in the direction. And one more thing you try to understand, if for any competitive exam, if you take Olympiad exams, there's a north pole and south pole, but magnetic north pole not be vertical this line, they will be at an angle of, it will be lies magnetic south pole and magnetic, they will be inside the, actually not outside, magnetic south pole and magnetic north pole, they will be at an angle of 15 degree. Okay, they will be at an angle of two lines that are aligned in an angle of 15 degree. Okay, this is a north pole, this, around this earth will going to rotate, but the magnetic north and south will be located at 15 degree with the rotation of the earth. They will be still, if you won't suspend directly north south, it won't come, it will come with an angle of 15 degree to the north south direction, if actually you want to take. Clear, children? This is about how magnet will be act like a, it will always suspend. Yeah, you can make your own compass. How are you going to make your own compass to find the direction? If some activities are given, you can take water. Okay, inside the beaker, you just take a water in a cup like this, and take one rubber cork. Okay, rubber cork. You have eraser in it. You know that eraser you're going to take. What happened? The eraser just going to float on the surface of water. Now you're going to take a iron nail. Okay, just going to take iron needle like this. Okay, what you taken, just you taken one iron needle, your iron needle, this iron needle, just you magnetize the iron needle. How you know, right? By magnetizing iron needle, by taking it to 10 times or 30 times, you're going to rub each other, it will get magnetized. This magnetized iron needle you're going to put like this. Okay, just you're going to immerse. So after, because it's magnetized, that means it will act like a north pole and south pole, right? So it will become freely suspended. Instead of suspending freely, you can do like this, suspend also, it will come to north south direction, or you can really release it in case of water, again it will come in north south direction only. So like this you are going to make your own compasses. Okay, so Chinese hanging compass they can call, and floating compass they can call. This is the two methods you're going to create your own compasses. Now this is clear, children? Yeah, I don't know how magnet was invented. In a great, okay, in a Greece, the person who was grazing the sheep, he went one temple. He went to some forest. There he going to see the stones. Okay, this is how he invented the magnet. Once you check. Okay. See your last slide. How are you going to preserve the magnet in a magnetic holders? So you want to keep the magnet in a magnetic holders like this. So always you're going to keep magnet in a magnet holder, so that what happen, its strength not going to waste. Or as magnetic field lines, its strength keep on going to waste from the north pole and south pole. So to don't want to waste, we want to place non-magnetic materials. In case of wooden boxes, we need to keep the magnet. Instead of keeping in iron boxes, what happen? It magnetic lines are forced continuously attracting, and magnetic going to not work. So how to take care of the magnets without loss its properties? We cannot heat. We are going to heat the magnet using from fire. We are going to heat, that time it will going to lose its properties, or we not going to break, or we not going to drop the magnet. When you going to drop the magnet from certain very high heights, no, that time also it going to lose its properties. Okay, these are the few methods we cannot, and we cannot hit the magnet, and we cannot break the magnet, and we cannot drop the magnet. So these are the some of the methods we cannot do to, and we cannot pass very high electric currents also. Okay, these are the methods to magnet going to lose its property. To avoid all these loss, we need to keep in a wooden boxes, so that it does not lose its magnetic properties at the strength. Okay, children, I hope this is about the fun with magnets chapter. I hope this is clear. Thanks for watching. Bye children. Have a nice day.